All right, guys, today we're going to look at lesson 6, which is percent composition. The easiest way for me to explain what percent composition to you is that think about when you look at the label of any food item. This is going to be the label of a side item for crackers. Okay? You have all of your amounts of fats, cholesterol, sodium, carbohydrates, and then you have your daily values. Your daily values this is the percent for fat out of a total calorie diet, which is 2,000 calories. That's the average diet, what you should be taking in a day. So if you have 1.5 grams over a 200 calorie diet, that's about 2% of your daily value. And that would be a percent composition, how much over the whole. So what actually is it for our class? The percent by mass of each element in a compound is what we call the percent composition. There's actually a formula for it. It's found located in table T, and it's percent composition equals percent composition by mass equals mass of the part over the mass of the whole times 100. So how are we going to go about doing this? So when we calculate a percent composition, you're going to first calculate the GFM, which is the gram formula mass of the compound. That's the mass of your whole. And then you're going to plug that into the percent composition for your formula. What does that look like? Let's look at an example. What is the percent composition of calcium in calcium chloride? So we're looking about the calcium alone in the formula calcium chloride. So the first thing we're going to do is figure out the gram formula mass of calcium chloride. So we have one calcium, has a mass of 40.08. We have two chlorines with a mass of 35.45. We have our individual masses. We're going to add them up. So the mass is 110.99 for calcium chloride. Now what we're going to do is we're going to plug that into the percent composition formula. So the percent by mass is going to be equal to the mass of the part over the mass of the whole. We need to figure out what the part and the whole is first, though. So calcium and calcium chloride is what we're looking at. So calcium is going to be our part, and calcium chloride is going to be our whole. So our percent composition is going to be equal to the 40.08 over the 110.99 times 100, and we get 36.11% of calcium. Let's look at a practice. What is the percent by mass of carbon in CO2? So pause your video and try this. You're going to follow the exact same example and then unpause when you're ready. Great, well, welcome back. So let's look at this. So first we need to do is find the gram formula mass of the whole thing. So we have one carbon with a mass of 12.0, two oxygens with a mass of 16.0, and we get a total mass of carbon dioxide of 44.0 grams per mole. The part is carbon in carbon dioxide, so part is carbon. Carbon dioxide is whole, so when we plug it in, we're going to put 12 over 44 times 100, and we get 27.3% of carbon. Let's look at another practice. What is the percent by mass of nitrogen in NH4NO3? Pause the video, unpause when you're ready. All right, so the mass, gram formula mass for the whole thing. So we have two nitrogens at 14.0. We have four hydrogens at 1.0 and three oxygens at 16 each. So our total mass for NH4NO3 is 80 grams. We want to look for nitrogen in that. So nitrogen's our mass, NH4NO3 is our whole. So we're going to take 28 divided by 80 times 100 and get 35%. Awesome. Now let's look at the check your understanding. What is the percent by mass of magnesium and MgCl2? We're going to go over this tomorrow in class, but I want you to try this tonight. All right, let's look at the next. Now we also have percent composition of hydrates. A hydrate is an ionic solid with water trapped in the crystal lattice. It's written like this. So we have whatever the ionic compound's formula is times some value n, which is a whole number, H2O. So let's look at this example. So we have CuSO4 dot 5H2O. So that dot shows that there are 5 water molecules that are attached to the one copper 2 sulfate molecule. So an anhydride is a crystal with no water trapped inside its lattice. It's the opposite of a hydrate. So how does water get trapped in the crystals? Crystal lattices, they have open spaces between the atoms, so the water molecules will get trapped in them. And the water molecules, remember, we've talked about this, have charged ends. One that has a positive charge and the other that has a negative. So they will orient themselves to be around the positive or negative ends in the crystal lattice. So what are everyday examples of hydrated crystals? The silica packets that you get in your shoes that absorb moisture from the air. Those crystals are going to be anhydride, and then when they absorb the water from the air, they become a hydrate. So how do we calculate the percent composition of a hydrate? First, you calculate the gram formula of the hydrate, including the water, and then you plug into the percent composition formula in table T. So if heated, the water of the hydrate will evaporate away. So any difference in starting and ending mass of the hydrate is the mass of the water. So let's look at an example. What is the percent by mass of water and sodium carbonate crystals? Here's our formula. So step 1, calculate the gram formula mass of the hydrate. So we're calculating the gram formula mass. All right, and when we get that all figured out, we get 286.1. The second step is to plug into your values. So your percent by water by mass is the mass of your water over the mass of the whole thing times 100. So let's look at this practice. What is the percent by mass of water in BaCl2 dihydrate? So pause the video, try this, and unpause it when you're finished. Great, well, welcome back. So we first have to figure out the mass of the whole compound. Okay? 244.3. Okay? So what's the percent? So the percent is the water, so the mass of just the water, over the mass of the whole thing times 100, and we get 14.7% H2O. Now what about if you're calculating percent mass of water in a lab? You would take, for example, a 2.2 gram sample of hydrate was heated to a constant mass of 10.2 grams. What is the percent by mass of water in the hydrate? So the water is heated or evaporated off, so the decrease in mass is the mass of the water. So you would take 12.2 minus 10.2, and you'll get, so you evaporated off 2 grams of water over the mass of the whole thing, which is 12.2. So 2.0 divided by 12.2 times 100 is 16% of water. So let's look at the second, check your understanding. We're going to go over this in class as well.